Agenda. In this short video, I'll discuss the following topics. Topic number 1. What is a student T distribution? A. Draw a student T density function distribution. B. Draw a cumulative T density distribution. Then C. I'll discuss two Excel functions, T.dist and T.inverse functions. Topic number 2. Construct confidence interval. And we have a formula. Mean plus minus margin of error. And later in the video, I'll discuss how to calculate margin of error, where we are going to use a data set. For the topic number 1, we are going to draw a student T density function and cumulative student T distribution. Okay, first one, so let's generate like x value. Okay, so let's start from -3. We enter -2.75. Okay, so this suggests we have incremental value of 0.25. Okay, so we copy and paste. So roughly from -3 to +3. Okay. We just remove something. Okay. And the first one we calculate density. Okay. So this is density. Okay. We are going to use T.dist. Okay. And so we have a degree of freedom. So let's assume n, we have 30 observation. Okay. So this is equal T.dist. Okay. X value -3, and degree of freedom is n-1. So this is n-1 because we calculate density. So it's 4. Okay, it's 4. And enter. I'm going to show the formula. Then we just simply type show formula. Okay, show formula of cell C2. Make it bigger. The function we use T.dist, B2, and so this is n, degree of freedom, and 4. Okay. Then we copy and paste. Oh, we have to log the F1. Degree of freedom is F1, so .f.1. Okay, then we copy and paste. Okay. So we highlight both columns. Then we click insert and recommended charts. So this is our student T density function. It's so close to the normal function. So it's a symmetric. You see the -3 and the +3. Okay. If you look at these two values, they are the same except the sign. So this is density function. So let's look at cumulative T distribution. Okay, cumulative distribution. And the only difference is we use, for the last input, we use true. Okay, so this is x. Degree of freedom is n-1. And we answer true because we calculate cumulative. Okay. Again, we have hit F4 to fix the n. Okay. So we highlight X and we keep the control key down. We highlight this one, then we insert recommend chart. And so this is our cumulative. Okay, and I'm going to use show formula. Okay, I'm going to use show formula to show the formula of this one. Okay. And if you compare with the original one, okay, you compare with the first one, you see t.dist, same function. Okay. b2, f1 minus 1, f1 minus 1. The only difference is false and choose. Okay. When the last input takes a value of false, we are talking about density. Okay. When the last value take a value of true, and we have the cumulative. Okay. And like normal, you see the 0 is 50, so it's a symmetric. Okay. And when we use t.dist, and so we are talking about probability. Okay, we're talking about probability. Okay, and suppose we want so this is 0.5, right? We know the value is 0. Okay, suppose we said here. So let's look at t dot inverse. Okay, dot inverse. So this is probability degree of freedom. Suppose it's 0.5. And degree of freedom is n minus 1. Okay, then we got 0. Okay, we got 0. Okay, show formula. Okay, show formula. Okay, and I'm going to make it bigger. Okay, so this is and from, if we use t.dist for a given x value, we calculate probability. Okay, I'm going to applying t.dist from x to probability. Okay, and applying and t inverse. We'll apply t inverse and from probability to x. Sorry, that should be no. So this is wrong. Show formula. Okay, so this is this one. So 0. Okay. Okay. I'm going to make it bigger. So we have two functions. Okay, for the first function, we apply t.dist, and for given x, we calculate probability. Okay, and suppose x is -2, the cumulative probability is 5.6%. Okay, and its opposite or inverse function, t.inverse, is opposite. We're applying t.inverse, we are given probability, we calculate x. X to probability, probability to x. So these two are like plus and minus, like multiplication and division, and like log, exponential function, and they are paired from A to B and from B to A. Next, we are going to discuss I'm going to discuss the density function. Okay. Suppose I'm going to draw a normal density function. Okay, so this is a normal, and it is symmetric, and we are going to suppose this is mean, and we are going to calculate confidence interval. Okay, and so let's assume alpha. Okay. So the alpha is like, let's assume it's 5%. Okay, so alpha is 5%. The confidence interval will be n 1 minus alpha. So actually this is 95%. So this is 95%. Okay, so what is the formula? So actually we have this one. So this is called margin of error. Okay, so this is margin of error. Okay. So the confidence interval will be x mean. So actually bar plus minus margin of error. Okay, so this is margin of error. Okay. Okay. So this is again, we are given alpha. We want to calculate confidence interval. Okay, and suppose alpha is 5%, then the confidence interval will be 95%. It's 1 minus alpha. And so this region is x mean plus minus margin of error. Okay, to calculate the margin of error, we have two cases. Okay, the case number one, sigma is given. Okay, sigma is given. When sigma is given, so the margin of error, okay, the margin of error will be equals, okay, I'm going to z alpha times, so this is standard deviation, square root of n. Okay, again, so this is given. Okay, so this is given. So this is z score. Why alpha divide 2? Because we have two tail. Okay, so this is half alpha, and this is another half alpha. Okay, eventually I'm going to show you how to use Excel function to calculate z score. Okay, so actually this score will be equals, so this is norm dot stand dot inverse and alpha divided by 2. So this is how to calculate z score. So this is case number one. Okay, so let's calculate for the case number 2. So sigma is not given. Okay, sigma is not given. Then our margin of error and equals, I use absolute value. Okay, the textbook didn't use absolute, and later I'm going to show you why absolute value is important. So this is also half. Okay, so this is sigma square root of n. Okay, and the difference is we calculate and sigma. Okay, the summary of this presentation is, suppose we have a distribution. So this can be normal, this can be student t, because they are all symmetric. When the n approaching a big number, t will collapse to a normal distribution. Okay, when we calculate the confidence interval, okay, so actually it's x mean plus minus margin of error. How to calculate margin of error? We have two cases. Case number one, sigma is given. Then because sigma is given, we have two features. The first one is we use the z instead of t, and we use when we calculate so this is this ratio called standard error. Okay, this is called the standard error. Okay, standard error is sigma divided square root of n. So n is number of observation. So number of observation is n. Okay. For the case number 2, sigma is not given. When we calculate margin error, we use t distribution. Okay, alpha divided by 2, alpha divided by 2. Why alpha divided by 2? Because for this case, we have two tail, and the left tail is half alpha. And in this case, should it be 5% divided by 2? So actually it's 2.5% on the right tail, and this is also 2.5%. Later I'm going to show you, I'm going to use data to calculate margin of error. Again, the mean plus minus margin of error will be our lower limit and upper limit. Between these two limits, we have 1 minus alpha percentage confidence interval.
Shutterstock Music.
Let's have a in-class exercise, okay? And simply type .ice, .ice, and so let's look at 34, okay? So just look at here, okay? And I'm going to copy and paste this one to Excel, and also there are three methods, okay? So the method one is much easier to get the data, and simply type .a Houston and .b if type .a. So Houston is the keyword for the data set, okay? And we are talking about chapter A, so data ID is 111. So type .b and 111. The launch Excel and paste it. Okay. If you are using Mac, then you see this is a link, CSV file. Alternatively, you can use this second link. I'm going to launch Excel and paste it here. Okay, paste it and paste it here. Okay, and so we are going to calculate. So according to the instruction, and we have standard deviation is given is 6. Okay, and the first one we use count. We count how many observations we have. Control Shift down arrow. Okay. In total, we have 64. So match here about 64 bills. Okay. So rest on bills, data were collected on the amount spent by 64 customers for lunch at a major Houston restaurant. These data are contained in the file Houston. So based upon past study, the population standard deviation is known with STD equals 6. At a 99% confidence level, what is margin of error? Develop a 99% confidence interval estimate of the mean amount spent for the lunch. Okay, and so we have AN equals 64. Then we can calculate mean. Okay, so this is mean. So actually, okay, I'm going to show the formula. To show this count. Okay, I'll make it bigger. Okay, and I'm going to hit F4 twice to lock the cell. You can see $A, $2. Okay, I'm going to copy the formula. Okay, so this is average. This is average. Average is 21. I'm going to show the formula. Okay, so we use average. Okay. Then we calculate. So this is confidence. Okay, confidence is given to 99. Okay, the alpha will be equals 1 minus confidence level. Okay, I'm going to copy the two functions here. Okay, oh, this is enter directly. So I have formula here. Okay, it's 1 minus confidence level. Okay, oh, this is enter directly. So I have formula here. Okay, it's 1 minus confidence level. Okay, based on the, so we calculate standard error. the standard error, so will be standard deviation 6 divided by square root of n. So according to our formula, okay, so this is given standard deviation divided by square root of n. So D2 is standard deviation, D3 with n, square root of n. So this is the standard error. So let's look at norm. Okay, so this is norm. So alpha divided by 2. Again, I mentioned alpha divided by 2. Okay, so this is norm s dot dist. Okay, the first one is z value, and we use inverse. Okay, norm dot s dot inverse. Okay, because we are given the probability. So probability will be alpha divided by 2. Okay, alpha divided by 2. Okay, again, according to the textbook, and sometimes confusing, is negative. Okay, we use absolute value. Okay, so this is margin of error. Okay, so margin of error will be our absolute normal and time standard error. Okay, so standard error. So this is our margin of error. Okay, so this is our margin of error. Okay, so we use the normal distribution. We use norm dot s inverse alpha divided by 2 times standard of error. Okay, so alternatively we can use absolute and this value times given standard deviation divided by square root of n. Okay, so this is directly we can apply the formula. Okay, so this I'm going to copy the formula here. Okay, so this is absolute value normal and times given standard deviation divided by square root of t. Okay, so this is lower limit. So lower limit will be mean minus margin of error. So this is mean minus margin of error. Okay, so this is upper limit. Okay, so upper limit will be mean plus margin of error. Okay, so then we have our. Okay, so this indicates our 99% confidence interval between 19.59 and 23.45. Okay, and we have second method to calculate margin of error. Okay, so I call the method. For the method 2, we use Excel function called confidence. See, equals confidence norm. Okay, so confidence norm, the first value is alpha, the second value is standard deviation because it's given, it's 6, size is 64. Okay, we got same result. Okay, I'm going to use show formula. Get it. Again, so this is confidence dot norm. Okay, so this is based on the normal distribution. When we apply the normal distribution based on the previous show, and when we sigma is given, so first input value is D7. D7 is confidence, so D7 is alpha. So this is alpha, standard deviation, and n. So this is method 2. Okay. So actually we have method 3. Okay, this is method 2. So we have the method 3. Okay, so method 3 is we calling a VBA called margin of ERR. Okay, so confidence norm is sometimes confusing, so there's a function called. Okay, so let's get to the VBA. Okay, so let's go to R. So let's go to R. You hit VBA. So VBA. So for the VBA, so let's clear it. Okay. Go to R, click VBA. Okay. So 59, VBA for margin of error. Okay. This up arrow key, so this is 59. Okay. Then we copy function and the function. So this is main function. The second function I call help function. Okay. Copy, go to Excel, click Developer, click Visual Basic, and paste it here. Okay, so actually I just paste the original, replace the original file. Okay, and the first one is called so equal margin of error help. Okay, there's no input. Okay, so it's show the usage of this specific function. Okay, then I'll type margin of error. Okay, the first one is alpha, exact as this confidence norm. So this is alpha, and the second one is standard deviation, given 6, and then is how many observations. Then we have exact same result. Okay. Okay, so this is show formula. Okay, so show formula. Okay, the bottom line is, so question number 1 is, what is margin of error? Okay, we apply the formula, then we can calculate margin of error. Okay, and alternatively, we can use Excel confidence norm. Why use norm? Because sigma is given. So here the sigma is given. Okay, the method 3, and you can use my VBA. It's simply called margin of error. Then we got the exact same result.
Shutterstock Music.